Hello, everyone. I hope you are all doing well as the week progresses. I bring to you a book review because a lot of you have asked me to do book reviews, and a lot of young people. I'm very encouraged because a lot of young people these days they want to start reading books again, and they want to start um, just going through everything, and they want to get away from this whole computer business, right? Just sitting in front of a screen all day long. That's something that I struggle with myself because I do not like screen time, but sometimes it's inevitable, especially when I'm making these videos. Other than that, I have no interest. But this is I bring to you today this book, The Theory of Groups. It was published by Oxford University Press in 1968. 1968, published in Great Britain. And it is one of my favorite introduction to the theory of groups ever written. I mean, even the preface is powerful stuff. And I'm going to go over the preface with you. But really, and I'll share some examples from the book with you. So I'm very pleased to share with you today those thoughts because it's a text that resounds with the elegance and precision one might expect from a serious treatment of group theory. And the subject itself, of course, is as central to the study of mathematics as it is to the understanding of the fundamental symmetries that govern both the abstract and the concrete. And you might argue that any book attempting to introduce group theory ought to uphold a standard of intellectual rigor. And that's an expectation MacDonald deftly meets with an assuredness that is rarely found in texts written for the more weak audiences. It's now the text, by the way, so again, it's called The Theory of Groups. It is not a leisurely stroll through the more um, less important, we'll say, aspects of elementary group theory. And you might find, such silliness in groups or, I'm sorry, books that were authored for those whose intellectual pursuits are more concerned with the immediate and the utilitarian. Engineering students and applied mathematicians. No offense, but we know this. That's the truth. We're being specific. We have to be specific when we criticize something. This is a work that is designed for those who recognize, as all true mathematicians do, that the elegance of pure theory is its own reward. The text begins talking about the fundamentals, and it's grounding the readers in the essentials of group theory. But it proceeds at a pace that it anticipates your familiarity with abstraction. So it is not a book for beginners. If you are a beginner, you might struggle with this book, right? But the examples themselves are palatable enough for even some beginners if you're very serious about what you're doing. There is an appendix as well at the end of the book and revision problems. Now, in Great Britain, sorry, let me see here, revision problems at the end. The text is small, the print. In Great Britain, by the way, revision means review, right? That's how, when I went to Imperial College in England, they used to, the first time I heard the word, we always used to say review in America, but they say a revision. Have you done your revision yet? Have you reviewed? That's how the English people use the term. Now, so it anticipates some familiarity because it begins with the fundamentals and it grounds you with the essentials. So if you are not used to this sort of thing, it's not a primer. It's a deliberate exploration of the fabric of symmetry. And MacDonald's, if you look at his treatment of the subject, is very rigorous. But he has a clarity of expression that one could only wish to see more often in texts that circulate among those who think that the true essence of a book is captured by the scent of its pages rather than the depth of its ideas. So the book begins with, through the well-trodden topics, the basic axioms of group, the silo theorems, but it does so, you get a sense of formality and depth that elevates these subjects above the level of mere technicalities. And as one personally, I have spent a great deal of time in the study of abstract algebra, but I found myself both refreshed and really delighted by the clarity. I've always liked this book because the clarity in which with which McDonald's guides us is just it's just a great book. We go through the intricacies of finite groups, conjugacy classes, and solvability. And the text, really, what I like about it also is it strikes an admirable balance between it's accessible in some ways, but it's also challenging in a different way. But some people that I know when I was back in under as an undergrad, I used to use this book already. I'm one of those people. I found this book when I was an undergraduate in the discarded books section. My college, Columbia University, used to have a in the library a it was like a cart where they would discard books often, and so they were free. You could pick them up for free, and because they were going to throw them away anyway. But some of my classmates, particularly the ones who were not engineers, they called it, they said that it was so pedantic. Oh, it's an exercise in pedantic complexity. No, it is a serious endeavor to engage the mind in when you're pursuing timeless truths rather than transient conveniences. But let me pause for a moment because I want to make an important point. This might ruffle the feathers of certain engineer types who they no doubt would have preferred McDonald's text to include more so-called practical applications, perhaps the symmetry of a mechanical object or the permutations of molecules in some chemical reaction. Now, those topics might have their own merit, but they are not the meat of pure mathematics. It is to the abstract world that McDonald's, his mind, willingly bends. It is written to be abstract, and he clarifies that in the preface. He offers us a glimpse of the mathematical landscape that most applied mathematicians will never truly appreciate. And if you are one of those people who find comfort in applying theorems without ever confronting the deeper truths of their foundations, you might do well to study this work and humble yourselves. You need to have a sense of humility when you come before pure mathematicians. And after all, group theory is not just about solving problems. It's about understanding the very language in which those problems are framed. And it is this high level of abstraction that makes McDonald's work that is so valuable to those of you who are true mathematicians, true math students. It gives you the insight into the inner workings of the tools that you need, the mathematical intuition that allows you to see through the surface and to understand the structure beneath. If you appreciate the beauty of clean definition and the elegance of proofs, this text will undoubtedly serve for you. It's a worthy companion when you want deeper mathematical knowledge. He goes through direct proofs. He doesn't do proof by contradiction, by the way. That's another plus of this book. So if you're one of those people who seek immediate gratification from real world results, you might find the journey too slow, maybe too abstract for you. Maybe you're just not cut out for it. But if you reside in the rarefied monastery, I call it, the rarefied sanctuary of pure mathematics, this book is a treasure. And it's a reminder that the true beauty of mathematics lies not in its applications, but in the contemplation of its abstract nature. So this is a work that's going to challenge and enlighten. And it's going to be of immense value to those who are if you're ready to embrace the elegance of pure mathematics without the distraction of worldly concerns. We're in a world where some reviewers, alas, they seem more intent in, you know, I can't believe I have to even say this, but they're more intent on smelling the book for its vibe rather than engaging with its true substance. And McDonald's work demands no such stupidity, superficiality. It is not the scent of the paper or the allure of trendy jargon that matters here, but rather the purity of the ideas contained within. You almost feel the urge. I mean, I'm sure you're going to agree with me, most of you. You almost feel the urge to slap the taste out of those who mistake such depth for mere fragrance. But of course, we have to maintain our composure. But let me read to you the preface, some of the lines in the preface. I mean, it's just great stuff. So Ian MacDonald was an Australian mathematician. There's not a lot of information about him, actually. If you look online, there's really not a lot of information about him other than this book. But I'm going to read to you what he said in the back of the book, in the description. He said, "This book provides a substantial first course in the theory of groups that is suitable for undergraduate courses in universities and will be of interest to those teaching modern mathematics in schools." And then he goes on to say that it's also introductory, that you do not need a background. Well, that might have been true in 1968. And I believe it because our math standards have plummeted in the Western world. So now it's a joke. So that's why I was saying that I don't think it's as user friendly as it would have been for sure back then. Um, because a lot of people back then already had a foundation in set theory by the time they got to college. But nowadays we don't even have a foundation in anything. So that's why I think it's a cautionary tale. But I want to read to you, by the way, the this by the way, interestingly enough, I don't know if anyone knows, this book used to, I don't know if anyone knows him, this book used to belong to it says from the library of James Lester James Lester Cox Jr. But I'm going to read to you the parts of the preface. It says, "The present work sprang from a course of lectures given to an Australian past class, when I found that no existing elementary text really met my needs. It bears many marks of its genesis in that fiery crucible." And then it goes, if you skip a few lines, it says, "Next, I have in mind the single minded concentration on groups to the exclusion of links with other mathematics and of applications. Experience shows that a course of this kind has to be self contained, as well as simple, and a glance at the appendix will show how little material is assumed known. Even Zorn's lemma and its cognates are passed over in silence and never used." And then I skip a few lines down here, it says, "It seems to me evident, if not self-evident, that even the humblest university student should be exposed to a little abstract algebra." Absolutely. I mean, this is great stuff. Absolutely. And high school students should be exposed to set theory. Remember my video, it's famous now. You need mathematical logic. You need sets. You need axioms. You need a foundation. You can't bluff your way out of mathematics. You can't Khan Academize your way through life. I'm going to share with you some examples. I don't have a lot of time today, but I'm going to share with you some examples from chapter 1 that might be interesting for you. Maybe chapter 1 and then chapter 2. Let me just look at chapter 2 where it says basic theorems and concepts. I might share one of those as well. Let me see if he actually included problems. Yes. There are some proof problems in here and questions about additive groups as well. So we're going to look at, I'll choose one of those from chapter 1 and then chapter 2. So on the board, all right, so hopefully on the board you can see this is from page 14 of the textbook. And he comes up with, this is from chapter 1, where we begin a discussion of groups. And it says, first, the definition. He says on page, in the introduction here, a group is a set and a binary operation. In that set, satisfying certain conditions. That is, the elements A and B in that order in the group called G define an element usually written as AB and usually called the product of A and B. The binary operation being conventionally called multiplication. But there are three axioms, three conditions. You have closure, G has to be closed under multiplication, and the associative law for multiplication holds for all elements A, B, and C in G. And also, you have an identity element. There is at least one identity element in G that is an element E such that AE, A times E that is, equals A for all A in G. So the first question on page 14, it says, discuss the following systems with a view to determining which of them are groups. The first one says I chose just because there's other questions here, but it goes up to, let's see, 6, 7, 8, 9, 10. There are 10 questions under number 1, right, in Roman numerals. So I chose 1 and 6. The positive real numbers with the binary operation of division. For any A and B that are elements of the positive real numbers, first we have to determine if there's closure. Yes, you do have closure here. Do we have associativity though? No, right? Because division in general is not associative. So therefore, it is not the positive real numbers under the division that do not constitute a group. The next one to note is the rationals with A plus B minus A times B taken as the product of A and B. Does that form a group? Well, we definitely have closure there. So closure holds. But what about the associative property? I did a little breakdown here for you. Have a look at it. This would be associative property taken with the condition here. You notice that both expressions are identical, and therefore the operation is associative. The next thing we have to determine, though, is the identity element. Now, the identity element must satisfy that A times E equals E times A equals A, for all A being elements of an element of the rational numbers. So if we use the operation definition, you have A times E and that condition has to satisfy the following operation, A plus E minus A times E, or you could write it as A asterisk E, but that has to equal A. And if we rearrange the terms, we could do E minus A times E equals 0. And you can factor out, excuse me, you can factor out the E. So you have E times 1 minus A equals 0. Now, for this has to hold for all A has to be in the set of rational numbers. The only possible solution here must be E equals 0, right? Because 1 minus A cannot be equal to 0 for all A not being equal to 1, right? So we could check 0. If you do A times 0, that has to equal A plus 0 minus A times 0. Which of course will equal A. And this confirms that we have an identity element, E equals 0. So far we have the conditions are being met. And of course the inverse is here, right? If you multiply by the inverse, you would get, if you solve for A to the negative 1, you would have a situation in which A cannot equal 1. So the expression will always be rational. So each element will also have an inverse. So what conclusion can we come up here? Well, we have closure, we have associativity, and we have identity, and of course the inverses, but those are satisfied. So this definitely forms a group, and you can now celebrate, I guess.